Okay. And how about number 5? What did you get for the period in number 5? 4. Very good. Because we take pi and divide it by pi over 4, which is pi times 4 over pi, which is all right, let's turn the page. Let's look at number 6. Which of the following is the vertical asymptotes of the graph? Now, let's not make this harder than it is. You don't think it's hard. You think it's easy. Let's remember what a normal tangent looks like. Where are the asymptotes in a normal tangent? Negative half pi and half pi, right? With no adjustments, that's where they are. When you look at problem 6, we're doing the tangent of 2 theta. What does that 2 do? That 2 cuts everything in half. Now remember, the originals are every half pi. So we're at pi over 2, I'll do it like this. We're at pi over 2 plus multiples of pi. Every pi after 1/2, I like to start with 1/2. Every pi after that, we're going to have an asymptote where k is some integer. Okay? Now, what are we doing? We're taking the normal and we're dividing everything by 2. So what does that mean? That means my asymptote is going to be at pi over 4. And then multiples of pi over 2, because everything gets divided by 2. Since the period is now half a pi, not pi anymore, it's half a pi, that means the asymptotes will be half a pi apart. And the first one is a pi over 4 now, because everything got switched up. Does that make sense to you? So the answer to number 6 would be C. If I define k as a whole number, I use the plus or minus. If k is an integer, I don't use the plus. All right. Now, you do number 7. Right now, you do number 7. It's the same question, but it's different period. What do you think? A, B, C, or D? C? C? I like that answer. How did you get C? This is the original. That will never change. That is the original. This time we are timesing by 4. So what was at pi over 2 is now at 2 pi. And a period that used to be pi is now going to be 4 pi. Yep, C it is. All right, let's do one more. Whoa, a little tricky, number 9. Think about what's going on there. And remember, this is the original. and we'll all laugh, right?
A.
Kidding. A?
Yeah.
Tell me why you think it's A, Charlie.
Well, it's just it doesn't have anything on the data, so that just means it's gonna be like starting point is gonna be a 0 for the main graph. It's gonna have a period of pi, and then
Okay,
it
so
says
let's stop there.
oh
He is right. The period's going to stay pi, which means this part is not changing because that tells you how far apart those asymptotes are going to be. The issue, I don't know. So
well it's shifted right by pi over 2.
okay, so let's look at the original. Here's the original. If I take it that way, pi over 2, then what am I going to have at pi over 2? Am I still going to have an asymptote at pi over 2? What am I going to
You're
have?
gonna have the
I'm going to have a 0, like a dot, intercept.
yeah.
Okay, so remember, I'm figuring out where the asymptotes are, isn't that right? Yeah, vertical asymptotes. So clearly, I don't have an asymptote at pi over 2 anymore,
Right.
so I can't start at pi over 2. I have to figure out where do I have an asymptote. So if you shift this picture, pi over 2 to the right, won't I have an asymptote at 0?
Yeah, you're right.
And then I'll have another one at pi. Now, there's still pi apart, so that part you were exactly right about. But I have to either start at 0, is that an option? Nope. Or pi, is that an option? Yep, so C, pi k, which would be like 0 plus pi k. So C is the answer? Did you follow anything I was just talking about? All right, here we go. Let's look at number 10. I don't have any idea what's going on here. Let's see. Let's look at number 10 and see if we can figure it out. A, B, C, or D, got a thought? C? Well, it's gotta be C or D, because isn't it upside down? So it has to be, A has to be bigger than, so it's C or D. Now, Leo, why did you say it was C? Why did you say B is bigger than 1?
Because the period is smaller than pi.
You hear what he said? The period is smaller than it's supposed to be. So that means whatever number we divided by has to be bigger than 1, because it's gotta make the period smaller. So C is the answer. All right, let's try the next page. Let's look at number 12. So remember, when we talk about phase shift, she's right, by the way, she's right. So your equation is tangent 1/2 x minus pi. So remember, this tells you where the new origin is. So in the original tangent, the origin is the intercept. In this problem, the origin would be at pi. Right, pi? That tells me that my period is now 2 pi. So I got an asymptote pi this way and an asymptote pi this way. And that's exactly the picture that we've got. Very good. Very, very good. All right, let's try one more. Let's see. How about 18? What are you thinking? 18, A, B, C, or D? D, very good. How do we know?
Because the slope is y over x.
The slope is the tangent, tangent's y over x, at pi over 6, your coordinates are root 3 over 2, 1/2. So when you put y over x, you get 1 over root 3. Does that make sense to everybody? All right, back up, look at number 15. The slope of the terminal ray is undefined. Which of the following could be theta? In other words, the tangent is undefined. The slope is undefined. Which one of those would have undefined slope? C. C has undefined slope because of 3 pi over 2. Your slope is, or your tangent is going to be 1 over 0. Not defined. Very, very good. All right, backside. Quickly, 20 through 28, get them done. This is all unit circle practice. Get them done, and we're going to go around the room and get your answers. scattered. 20 is 1 over root 3. Right? 1 over root 3. How about 21? Negative 1. Good. 22. Negative root 3. 23. Negative root 3. 24. Negative 1 over root 3. 25. 0. 26. Undefined. 27. 1. And 28. Root 3. Anybody have a question about any of those? You gotta watch your SIGNs.
What was 26 again?
26 was no answer, undefined. Okay, all right, you got some space at the bottom of that page. I want you to write this equation down and we're gonna graph it. First thing I want you to notice about that equation is what? You're going to have to factor out the 3. Does everyone notice that? You do not want that coefficient inside the parentheses, so you're going to factor that out. And then you're going to start sketching. So go ahead. When you feel like you have something good, bring it on up and put it on the board and we'll compare notes. phase shift was going to be negative pi over 3. And then a tangent, the origin, the original origin, is an intersect or a dot. So that dot is now right here. And then you figured out that your period was pi over 3. So that means from asymptote to asymptote, the asymptotes here is pi over 3. This is pi over 3. So from here to the asymptote would be pi over 6. So I have an asymptote at negative pi over 6. so I'm gonna squiggly line. Under normal circumstances, halfway in between my intersect and my dot and my asymptote, I would be up 1. But because of that, I'm only gonna be up a half and down a half. So basically, I've got a curvier, a flatter tangent, because it got multiplied by a half, which means it got switched shorter. Everybody okay with that? All right, let's get our notes back out then. And we were on the back of page 7. And we're ready to talk about example 3 on the back of page 7. I gotta watch. Now, we need to remember, in order to do all of these problems that we're getting ready to talk about, we need to remember that inverse sine and tangent are what we call right side functions. They exist only on the right side of the unit circle. And they exist only between negative pi over 2 and pi over 2. So if you are using either of these, then you can only answer in this interval. Your answer has to come from that interval. If it's an inverse cosine, then remember it's a top half, and your answers have to be between 0 and pi. Okay? So if you haven't already committed that to memory, you need to, so that we make sure you're gonna get the right answers for all these problems. All right, here we go. Terminal ray intersects the unit circle of point P, which is x comma y. Q, R, and S are reflections of that. Okay. Determine which labeled point intersects the terminal ray of the given angles. Well, A is an inverse cosine. So the only possible points would be P and Q. Because inverse cosine only exists up here. That X is positive, so which point is it? P. It's gotta be P, it's gotta be in quadrant 1. Now what about B? B is an inverse sine. Your answer has to be either P or S. But that's a negative number, so it can't be P, it must be S. How about C? Which point is that? Q. Q. And how about D? Has to be S. Has to be S. Nothing is ever going to be R because none of your functions are defined in quadrant 3. You're never going to have something in quadrant 3. It's either going to be in 1, 2,
Can you say that one more time? I got lost.
for which one?
All of them?
Yeah, say what?
Then
A. X is a positive number. X is X point X comma Y. That's X is positive, Y is positive.
Yeah.
Inverse cosine can only happen here. So does quadrant 1 or quadrant 2 have a positive X value? That's quadrant 1. Yeah. All right, let's move on. Next page 9. What is the sine of 7 pi over 6? circle, 7 pi over 6. Sine is 1/2 negative, very good. How about negative pi over 6? It's still negative 1/2. What about 11 pi over 6? Still negative 1/2. And I bet D is also, but let's see, 19 pi over 6 would be the same as 7 pi over 6, so that's negative 1/2. So the answer to all of part 1 is the same. Can you understand that? Because aren't we just going around the circle? Forwards and backwards. Now let's plot them on this graph. So 7 pi over 6, negative 1/2. So go ahead and plot it on the graph. Negative pi over 6, 11/6, which is almost 2, and then 19/6, which is a little bit bigger than 3. You see how they're all on that negative 1/2 line down there? Solutions are there to the question that says the sine of an angle is negative 1/2? How many solutions are there? Well, how many do we have in problem 1? We have 4 of them in problem 1, right? Are there more than 4? Let's keep going forever. We talked about this yesterday, and that's a problem, because when we find the inverse then, we can't have infinitely many answers. So, there are infinitely many answers to this equation right here. Infinitely many. But as soon as you insert this notation, which is basically saying the same thing. This says what angle has a sine of negative 1/2. This says what angle has a sine of negative 1/2. But as soon as you put that notation into the problem, then you no longer have infinitely many answers. This has infinitely many answers. This has 1. What is the one answer to that question? Negative pi over 6. Because of all the infinitely many answers, look at 4 of them in question A. There's 4 of them. Of all the infinitely many, there is only 1 that falls in that domain. Is y equals sine theta 1 to 1? No. Why is that important? Because that means its inverse isn't a function. So we've already restricted the domain. We've done that. I turn the page. Let's look at number 1. Evaluate each expression or explain why it's not possible. Remember, arc sine is the same as inverse sine, so don't be confused by the notation, it's the same thing. So arc sine of negative root 2 over 2 is the same as inverse sine. Those are exactly the same. Alright, so what do you think? What is the answer to that question, Charlie? Negative pi over 4. Charlie says 1 over root 2 is a pi over 4 angle. It's a negative, therefore it's got to be a pi over 4. Negative pi over 4. Perfect. What about B? Remember, that's 1 over root 3. It's rationalized, but it's 1 over root 3. So what kind of angle is that? Pi over 6. And since it's a tangent, it will have to be the same as this, which is find the angle whose cosine is 3 pi, which is like 9 point something. Can a cosine be 9 point something? No way. Because go way back to the beginning. In your triangle, isn't cosine adjacent over hypotenuse? Could this be 9 and this be 1? Not doable. What are the limits on cosine and sine? Negative 1 and 1. They don't go lower than negative 1, they don't go higher than 1. So that problem has no solution. No solution. Oh boy. Look at number 2. Well, you think about it, talk about it. I'm going to try to write it down. Just trying to figure out if it's true or false. I think we have one of each. We have a false one and we have a true one. I want to hear your ideas on that. Anybody have a thought? Charlie?
I think the first one's false.
Why do you think the first one's false, Charlie?
Well, first of all, just looking at the answer, you can't have 5 pi over 6 be a sign.
Yes! You can't have 5 pi over sine, or 5 pi over 6 be an answer to an arcsine problem. Arcsine problems have what kind of answers? Negative pi over 2 to positive pi over 2. And 5 pi over 6 doesn't fit in that. Very good. You just made this a happy day for me. All right, what about number 2? Why do you think it's true, Leon?
Because we have to use the bounds of like pi over 2 and pi over 2.
Now watch it, this is cosine.
Oh, sorry, I meant 0. It never gets outside of that. And so when you put the negative 2 over 2, you get
This right here would be this angle right here, which is 3 pi over 4. So this right here says the angle whose cosine is negative root 2 over 2. So it's a pi over 4 in quadrant 2. And then it says, okay, you got this angle here. Take the cosine of it. What was the cosine of it? Negative root 2 over 2. So he is exactly right. That one's true. Top one was false. The bottom one is true. A. 3. How many values satisfy the equation tan x equals negative 1? How many angles have a tangent of negative 1? Well, they're going to be 8 pi over 4 angle, but it wouldn't be pi over 4, it would be in quadrant 2 or 4. Well, how many of those are there? Well, there's 2 in one revolution, but wouldn't there be infinitely many? I could keep going around and around and around. So there are infinitely many answers to that question. 3 pi over 4, 7 pi over 4. 11 pi over 4, 15 pi over 4, and so on and so on and so on, infinitely many. But how many answers does question B have? 1. And it would be negative pi over 4. Not 3 pi over 4 and 7 pi over 4 and all those other things. Just negative pi over 4. Alright, one of these is false. Number 4. Let's see if we can figure this out. Only one of them is false. Which one do you think is false? C? Why do you think C is false? I mean, I haven't drawn, you may be wrong, or you might draw, but remember, here's the cosine. And for the cosine, we're only allowed to look between 0 and pi, so I'm only looking at this part right here. So then I went ahead and did the inverse. So I switched my ordered pairs. So 1, 0, 0 pi over 2, and negative 1 pi. So this is the inverse. So I notice either on the original or here, it doesn't make any difference, or the original, aren't my v values automatically between negative 1 and 1? That's what we just talked about. Cosines go between negative 1 and 1. And then your A values are from 0 to pi. Because that's the only part of the curve I like to look at. D, good review question. D says the graph of F, which is a cosine curve, it says if you plug in a negative, it doesn't change your output. So if you put in a negative, you still get B. What is that a characteristic of? That right there is a definition of what? An even function. And cosine is even. So D is true. A, B, and D are 100% easily verifiable. As, who answered it? Leo said, if you add 2 pi, then you're leaving the range you're allowed to be in. So C is indeed the false one. Perfect. All right, let's look at the other sheet, another sheet I gave you, and it is called 5 for 5. I think we did one of these before. Anybody remember us doing a 5 for 5 before? Here, a thing Mr. Passwater came up with, and his conjecture is that, you know, the best score, the score we're all going to get on our AP exam is 5. He says if you can do all 5 of these, you are on your way to a 5 on the exam. So there's an easy, really easy one, there's a couple medium ones, and then there's a couple more difficult ones. So right now, either by yourself or with your partner, let's see if you can come up with the answers here to this 5 for 5. And then as you get them, we'll have you come up and put them on the board. It's the front side only of the paper, so I don't know what's on your back, it doesn't matter. It's the front side only. doing it. Let's look at this now, let's check and see. Number one, A is the conjecture, do we agree? Love it. Love it. How about B? Or two, I mean, there's two B. No issues there. Alright, three is C. What do you think about that one? You okay with that one? If you didn't get that one, remember that what the question is saying literally is find the angle whose cosine is the sine of 5 pi over 3. Do we know the sine of 5 pi over 3? We know this, right? We should know this. What is that? 5 pi over 3. Negative root 3 over 2. So the problem is saying what angle has a cosine of negative root 3 over 2? And it definitely has to be over here in this quadrant, cosine. And root 3 over 2 for the first coordinate is a pi over 6. So 5 pi over 6. And that goes with these angles. Yep. Is everybody okay with that? What about number 4? We agree with that? Anybody can get an answer to that one? Annie? What? C? That's what I got. Let's look at number 4 for a second. Number 4 says, I want you to listen, I'm going to read this problem. Okay, I'll read it. It says, find the tangent of the angle whose tangent is 2 pi over 3. So in other words, there's an angle out there whose tangent is 2 pi over 3. And what do I want to know about it? I want to know its tangent. Who's buried in grants 2? The tangent is 2 pi over 3. So what's the tangent? 2 pi over 3. Now, this is bothering some of you, I can tell. This is a number. That number is about what? What is that number? 2 pi over 3 is 2? 2? So what if I make that number 2? It's about 2. The angle whose tangent is 2 would be in quadrant 1 because it's positive, and it would look something like that, right? So that's a picture of this. Now, look at that picture and tell me the tangent. 2? Right? So that's why the answer to question 4 is 2 pi over 3. That's your 5 question right there. That's your 5. Okay, and then number 5, what did you get for that one? Find the angle whose cosine is the cosine of 5 pi over 4. Now, you might be tempted to say, well, 5 pi over 4, but you can't, because as Charlie so eloquently put it a while ago, that's not in the range. What do you think the answer is? This person up here said C, was he right? is that? That is negative root 2 over 2. What is the angle whose cosine is negative root 2 over 2? It's got to be in quadrant 2. 3 pi over 2. Let's practice a little bit more. Get off the last packet I gave you today. It's not a packet, it's one page. Yes? Worksheet A, topic 3.9. Don't overthink problems 1 through 6. Answer 1 through 6. We're going to have to go to lunch here pretty soon. I know you're thinking, okay, God, but you got to get 1 through 6. So let's see about the answers to 1 through 6. Only one answer for these 6 questions, each of the 6 questions. What'd you get for number 1? Oh, let me call on someone. Pi over 3. You are absolutely correct. Pi over 3. Paisley, what'd you get for number 2?
Negative pi over 4.
You are absolutely correct. 2 for 2 so far. Let's keep it going. Cole, what'd you get for 3? All right, we'll keep working away there. Parker, what'd you get for 3? Pi over 4. Perfect. Number 4. Alberto. Perfect. 5 pi over 6. Number 5. Sylvia. For number 5? Okay, a couple of things about that. One is, this is a sign question. So whatever you say is the answer has to be where? Between negative pi over 2 and pi over 2. Okay? So think of it as between negative 1/2 and positive 1/2. Alright? So 5/3 doesn't fit that right out there. I do like the fact you're in the 4th quadrant. You are, because the answer has to be in the 4th quadrant. But if the sign is a half, is that a pi over 3 angle? I think that's a pi over 6. So the answer would be negative pi over 6. And last one, number 6, Sydney, negative pi over 6. That one also. Those are very basic problems. Does anyone have a question about those problems? next time I see you, which is not tomorrow, the next day maybe, we're gonna have a small little quiz, right? We're gonna do two things on this quiz. One of the things you're gonna do is answer one question like the 6 we just did. Okay? One question is it. Because with one question, I can tell if you know your unit circle and if you know your rules, the inverse signs or something. Okay? The other thing you can do is graph one period of a tangent. So we did one earlier, we graphed the tangent earlier, we graphed 3 yesterday. So you have that to practice. You want to graph one for me, not multiple choice, you build the graph. And then the one problem like this. Everybody clear on that? It's a little short half page, won't take very long. We'll do a little more of this and then move into 310. Alright, let me just double check my time schedule. Gather up the things, grab your phones, have a great day. I will see you in a couple of days. Oh, yes, thank you. 3.9 is assigned today, so it will be due on Thursday. 3.9 is due on Thursday.